Dear student, in this session we will see what is critical phenomenon. We will discuss about Andrews experiments which he conducted in the year 1863 using carbon dioxide. This experiment studied the behavior of carbon dioxide to understand the transition between gas and liquid phases. And this experiment introduced the idea of critical points. So this is the apparatus used by Andrews. You can see this is a container with a constant volume and there's a screw to increase the pressure, and this container with the strong walls was filled with water, and the gas whose critical points or critical temperature, pressure and volume to be determined is filled here, and this is filled with this column is filled with nitrogen, and you can see mercury here in both the columns, and this is used to measure the pressure. He took carbon dioxide gas in the strong glass tube, and then what he did, he increased the pressure and he obtained a graph. Okay, he plotted a graph of P versus V. In a simple way, if you want to understand what he exactly did is, he kept on increasing the pressure till the carbon dioxide vapor phase gets converted to liquid phase. He gradually increased the pressure, not suddenly, okay, keeping the temperature constant. He did it at various temperature and observed how this carbon dioxide gets liquefied. So this was the graph obtained. If you see the graph behavior of carbon dioxide at lower temperature like 13.1 degrees Celsius, when you increase the pressure, okay, by turning the screw, you can increase the pressure here. Go on increasing the pressure. After a certain point, there will be a sharp decrease in volume. So what do you expect? See, if there is a gas, you increase the pressure continuously. Anyway, volume is going to decrease because increase in pressure at constant temperature will decrease the volume. You know it from the gas laws. Now, if there is a sudden decrease in volume, what does it indicate? The gas is converted to liquid because under high pressure, the molecules come together and gas will be transferred to liquid at certain temperature, especially when the temperature is low. Now at 13.1 degrees Celsius, you can see when you increase the pressure, suddenly volume decreases. And here there's a sharp decrease in volume, then not much decrease, it remains constant. Because once the gas is converted to liquid, you may apply higher pressure, but liquid compression is not that easy. So there won't be any much change in the volume of the liquid. So this is what is happening. So you increase the pressure, now you increase the temperature every time. So instead of conducting at 13.1, now you conduct at 21.5. Again you increase the pressure, volume will decrease and it will be converted to liquid. So Andrew did at various temperature. Then at one particular temperature like 31 point close to 31 degree, he observed it was getting converted to liquid, and this was the last temperature. Because when he increased the temperature 31 to 32 degree, even if he increases the pressure very high, the gas was not getting converted to liquid. It was remaining as gas. But see, if you come back now, again if he increased the temperature, again at 35 somewhere around 35 degree also, gas could not be converted to liquid. Again, if you increase the temperature, gas cannot be converted to liquid. But at this particular temperature, roughly around 31, because this is known as the critical temperature. This is the maximum temperature above which you cannot convert the carbon dioxide gas into liquid, even if you increase the pressure by any time. I mean, even if you increase the pressure very high. So this particular temperature, Andrew termed it as critical temperature. Okay, this is the critical temperature of carbon dioxide. And the pressure measured at this particular temperature is specific, this is called critical pressure. And the volume of the gas occupied at the critical temperature and pressure is called critical volume. So these are the critical constants of any gas. They are Tc, Pc and Vc. Tc is critical temperature, Pc is critical pressure and Vc is critical volume. Critical temperature is the temperature at which a substance can exist as a liquid. Okay, it's the maximum temperature, and above this temperature substance can exist only as a gas. You cannot convert it into liquid even if you apply very high pressure. So this maximum temperature is called critical temperature. And the minimum pressure required to liquefy a gas at its critical temperature is called critical pressure. And the critical volume is volume occupied by 1 mole of the substance at critical temperature and pressure. So you can see this table. These are some gases with their critical constant Tc, Pc and Vc. Hydrogen, helium, nitrogen, carbon dioxide, ammonia. You can see this is in Kelvin. Okay, hydrogen critical temperature somewhere 33 point this, ammonia 405, and this is the pressure under various pressure. I mean the pressure required at critical temperature, and this is the volume occupied by this. So you can make out one conclusion here. See here, critical temperature of ammonia is high. That means it is, what does it indicate? 405. Okay, and here if it comes hydrogen is very low. So these ammonia type gases, water, carbon dioxide, they can easily be liquefied. If the critical temperature is high, then at higher temperature only with certain pressure you can liquefy that. But critical temperature is very low means those gases cannot easily be liquefied. Okay, like hydrogen, helium, nitrogen, you need to bring the temperature very much low if you want to liquefy. They are a bit difficult to liquefy. So you can also make another conclusion using this. You can say this carbon dioxide, H2O, ammonia, these are a bit polar. They have dipole ends, oxygen, nitrogen, hydrogen attached to nitrogen. So because of this, there will be more force of attraction between the molecules. So that's another reason why they can easily be liquefied. So if this water, if you see, it can easily be liquefied. So water gas, it exists at somewhere, at more than 100 degrees Celsius. But so you can easily liquefy the water. At room temperature, water is a liquid. So the critical temperature is very high. Hope this is clear to you. These are some of the reference books and online resources for this study material. Thank you. Thank you for watching.